Hello, everybody. My name is Anthony, and I come to you today from a different location. You'll notice that some of the other videos that I produced, the first two, were produced in my apartment, and I made a bunch of shorts after my second one to correct some of the mistakes that I had made in that video. I recorded those in my truck while I was on lunch break at work. But now I have moved out of my apartment, and I now have a dedicated studio space with, lighting, the backdrop, my microphone and everything all set up in an area where I can have some more high quality content produced. But today I come to you with the long awaited electromagnetism video. And personally, I do think that this is some groundbreaking evidence against the evolutionist paradigm, specifically the paradigm that posits a really large timescale. Now, I have introduced that idea in the past, especially when it came to radiometric dating and that kind of data, but this is some big evidence. And this time, instead of just reading off of a script that I made, or not having a script at all, this time around, I took the duty to make a presentation. So, this is Debunking the Atheist Zeitgeist, Part 3, Electromagnetic Dynamics and Impossible Processes. So, what I'm going over in this video today is what the current narrative is about electromagnetic dynamics, the age of the Earth from the flipping in the magnetic field. I'm going to be going over what goes undemonstrated by some of these claims that are made or some of these models that are produced. I will be discussing the physics behind the generation of a magnetic field, and I'm going to be talking about magnetic anomalies. I apologize, give me a second. I'm taking off my pop cover. It's getting in the way. And finally, I will propose an alternate theorem which describes everything that we see about magnetic anomalies, the projection of the magnetic field, and everything. Although magnetic field thing will come closer to the middle of the video, my alternate theorem has more to do with the magnetic anomalies than anything. So, starting with the current narrative, we have magnetic strata, which these are basically striations that are present within rock formations. So when you take a sample and it has a high iron content and you take it from a specific area, you can see that there are different magnetic structures within that rock. You have some that point in one direction, you have some that point in another direction, and if they're kind of meshed with alternating stratifications, then you can supposedly date that structure in the geologic column based on that data. So the way that this started as a method of measuring time data, there were projects that were going on in the mid-Atlantic at a place called the Mid-Atlantic Ridge Anomaly, which is something I'll go over later. Boring samples were taken from there to measure the different stratifications in the rock. That was basically just the beginning of that. But also part of the current narrative is that the signature flips as an indication of timescale, because you can take those stratifications and place it to a certain period in time for when the Earth's magnetic field was facing in one direction or facing in the other direction. And so with the assumption of constant material addition and a constant flipping of the magnetic field, you'll see these different stratifications. I will get more into the physics on that later into the video. They also connect this stratification data to radiometric data. So if you see geologic timescale or something called the geologic column, most of those data points are provided first by radiometric data, and then it's corroborated to other information specifically regarding signature flipping. And so if you have a certain specimen which is carbon dated to be however many years old, and it shows up in this area of the geologic column, then you can only assume that there's been X amount of time between each stratification, and in each of those strata, you can approximate when the magnetic field had flipped. And when it comes to magnetic field reversal, the assumption is that if there's a flipping in the magnetic signature, then there's a field reversal. And that said reversal corresponds with some period in time. So here's what goes undemonstrated in these theories, or in these, I guess you could call them constructs. What goes undemonstrated is first that field reversal causes signature flipping. I'll get into later why that is something which is undemonstrated, because the magnetic field is not the only variable involved with that. There's the idea that strata correlates to some vast time period based on radiometric data, and the assumption of material addition is going to be extreme enough to produce such a signature in those rocks. And the final thing that goes undemonstrated is that field reversal occurs and is possible under current conditions. And again, I will go into this pretty soon, but we're going to start with the physics. The equation that you see on screen is the magnetic force equation. So usually the way that it would be usually the way that it would be shown would be F sub B. F sub B is denoting magnetic force, but I simplified it for the sake of brevity here. You have the force, and the arrow just signifies a vector. The force is equal to Q V cross B. Q in this case is the charge of some particle, or the charge of some body, but calculating for bodies can be a bit tedious. The equations are a lot more complex than just this, but this is the basic. Take some charged particle with charge Q, and you move it in direction V, and you take that with the cross product of vector B. B here is magnetic field. You take the cross product and you get force. So when I was in school, the way that we were taught how to understand this was with something called the right hand rule. So with the right hand rule, you basically take your hand and you make a kind of like a corner of a cube with it. So you have your thumb pointing up is the force, and if you have something moving in this direction with this magnetic field influence, you should expect this force. This is effectively what cross product is. It involves a bunch of linear transforms, but that's too complicated to get into for this. Basically, the way that we should be referencing this is with this: force, velocity, magnetic field. So if you have something just moving in this direction, you have a field, and you have a field pointing this way, you have a force that goes up, and you do the same thing in the opposite direction. So if you have something moving this way in the same magnetic field, you're going to have a force that points down. This will become very relevant in discussing the magnetic field anomalies. But the next topic is fluid dynamics. So inside of the Earth, you have your crust, which is the outer layer. You have the mantle, which is a sort of non-Newtonian fluid. Is usually how it's described. And then below that, you have what's called the outer core, which is liquid, nickel, and iron, usually, for the sake of brevity. And then you have the inner core, which is solid, nickel, and iron. What I like to use in describing this, which I'm about to describe, is using the example of an automatic transmission in a vehicle. And I know this sounds ridiculous, but I do have professional training in the field of automotive mechanics. So I picked this sort of thing up in my training, and I thought of it as a decent analogy to use when describing this. In an automatic transmission, you have two sides. You have one side, which is called the pump, and another side, which is called the turbine. The pump spins, and the turbine spins with the pump. And it's a fluid, it's what's called it's like a fluid drive. So in between the pump and the turbine, you have a bunch of fluid, and the fluid turns with the pump, and the fluid drives the turbine. And at peak efficiency, you should expect the energy transfer from the pump to the turbine to be at 80%. This is why you have such things like stators. Stators will increase efficiency, and clutch locks, which basically, once the pump is at peak torque, or even at peak speed, you can lock it to the turbine so that they're spinning as one unit. So this mechanical connection, you don't have to worry about some sort of fluid coupling or fluid connection. Now, if we're to take this and apply it to the dynamics of the inside of the Earth, you have your solid crusted mantle, which acts as the pump, because due to inertia, it's going to continue to spin around regardless of what all is going on inside of it. So as the Earth is spinning around like a pump, it is also driving the fluid of the inner core. And this fluid of the inner core is subsequently going to drive the inner core, the solid inner core. So you can think of the solid outside of the Earth, crust and mantle. You can think of that as the pump, and the inner core as the turbine, and the outer core as some kind of a fluid coupling. So when you have a fluid that has varying levels of friction within it, you're going to develop what are called eddies. And these eddies are basically like if you have two things that are moving at different speeds, the one that's moving faster is going to cause some internal current to generate in between the two surfaces that are moving. So if you have one that's moving faster and one that's moving slower, you're going to develop an eddy, which is going to be which is going to be turning towards the slower surface, and it will rotate back around. So if you can imagine, inside of the Earth's core, you have the faster moving mantle, which are producing eddies within the fluid coupling that is the outer core. And these eddies are being produced all around the sphere of the Earth. These eddies are going to be what produces the magnetic field. So if you kind of think of the magnetic force equation in reverse, you have a sort of a force that is applied, friction in this case, and this friction is inducing some kind of magnetic interaction. And because this interaction is consistent all around the inner core, you're going to develop a magnetic field which points in a consistent direction and is going to stay somewhat consistent, but it's going to remain in its current directionality. The only way that this could ever change is if the direction that the Earth is spinning in changes. And I really don't think that it would be something that some evolutionist component would conceive of, to say that every 20,000 years the Earth changes the direction that it spins in, because this would be catastrophic to their paradigm. There's no way for them to justify this. There's no scientific evidence for this. And that's the one thing that they always harp on theists for, is you have no evidence. Well, it's physically impossible for this phenomenon to happen unless you just spin the Earth around the other direction to produce a magnetic field that's pointing in the other direction. Yeah, those strata, they don't just appear because the magnetic field reverses. That's ridiculous. The internal forces don't change unless they're prompted to change. That's it. End of story. This is not something which is even remotely possible, let alone something that occurs regularly every 10 to 20,000 years. Like, that's ridiculous. Anyways, what I have on screen now is a diagram showing what's called the Mid-Atlantic Ridge anomaly. So basically, where you have two tectonic plates converging, where you have them converging, and then you have some material addition, supposedly. This is present in the middle of that kind of plate ridge, in the middle of the Atlantic. And so they took measurements of the magnetic field signature in various places along that ridge. And that's what this diagram shows. So the red, you have a signature which is pointing upwards, and in the blue you have a signature which is pointing downwards, which is measured in nanotesla. Tesla is just a measurement of magnetic field, effectively. So if you were to fit this to the current narrative, what you would have to assume is that in each of those lines of stratification, or in each of those strata, each strata represents a period in time when the magnetic field was represents a point in time in which the magnetic field was pointed in some direction. So assuming that the magnetic field has been how it is for the last 150 years, or 150,000 years, you would expect to see the large strata in the middle. So there's two bold lines, a bold blue line and a bold red line that goes all the way down. The assumption would be that there's material addition, which over the last 150 years flows in a certain direction and produces a signature that we see right there. Not to mention that just doesn't match what their data would have to assume. Because if we're going back to the physics equation, or right-hand rule, in order for the positive signature to be produced, you need a force in that direction which will produce the paramagnetic effect that you see, which produces the field. So unless your iron microstructures are pointed within a certain direction, in this case, if you look on the bold red line, they would have to be up. There would have to be some force which would induce that signature, which would be an upward force, in order for an upward force to happen, you have to have something moving towards the center. Same thing on the blue line. In order to have that signature be negative, it would have to go this direction, which just goes completely contrary to the actual data that we have. So we have magnetic lines of flux. Actually, sorry, I got that wrong. I'm going to correct myself. I'm going to correct myself live. The field is pointed the other direction. So if you have yeah, it'd be kind of hard to reverse my hand like this. But if you just imagine that in the reverse direction, you have something moving this way, magnetic field moving this way, you have a force pointing up. So what you see is what would be expected. That was a quick correction, my bad. What you see is what would be expected if there was material addition over some stretch of time. And after every one of those strata, you see it alternates between red and then blue, and then red, blue. It's kind of uneven. It's not very evenly spaced at all. Unfortunately, this is the only piece of data that is actually given in this study, that they have this sort of area that stretches around, and then that's it. Everything else is just, it's kind of just formed like that. I don't think that's actually from data that they collected. All this more dense information in the center here would be from what they had collected. But what you can see, there's a couple things that could be said about their formation. So you could either have some material moving in some direction, and sorry, there's a fly. You have some material moving in some direction under the influence of some magnetic field to produce a force which would align the microstructures in the iron in order to produce the signature that we see. You also have another explanation, which I'll get into just right now. So here's my alternate theorem. What can cause the stratification? So you have the first option, and these are all things that I've thought about for a little bit. You have a high temperature collision with rapid cooling. So really, in order for these microstructures to actually be produced, you'd have to heat up the material past its Curie temperature and cool it in such a manner which would allow it to retain its magnetic microstructures. So if you have something that's moving in this direction under a magnetic field pointing in that direction to get a resulting upward force, you'd have to have some kind of rapid movement of the material or some kind of shock wave which was rapidly cooled down. So some postulate for that, and I know this is going to be kind of ridiculous at first glance, ridiculous at first mention, would be something like an underwater aquifer shooting up from these anomalies and causing so much friction that it heats up the rock around it. And when the rock finally collapses back onto itself and cools down, it sends a shock wave, a very high amplitude, high energy shock wave in one direction, and then after some settling, it goes back in the other direction, and then it just flips back and forth until it's completely cooled down and homogeneous with the rest of the area. And this would go for wherever that shockwave would travel within the rock. And this isn't something that I necessarily have fleshed out completely. Could use a bunch of work, but you could also take the postulate of plate settling. So basically, if you have plates that are kind of loose, or kind of, I wish I could call it more plastic, they'd be a bit more malleable and be able to move around a little bit easier. And if in the process of cooling, you have a shift in one direction, and then a shift again in another direction, and then it continues until it stops and completely cools down. This would also explain the stratification, and would actually explain how it penetrates through layers of the rock, because it's not going to just, it's going to cool less. It's going to cool less quickly as you get lower and as you get more insulated from whatever condition is causing it to cool. It's still going to be relatively malleable underneath the surface. So it's going to keep settling, and it's going to cause those stratifications because the actual movement of the plate is providing the velocity in that magnetic force equation. And so as the velocity changes, so too does the signature change. And then, the final one would be just the common theorem, material addition and field reversal. But it's already been demonstrated that one of those, field reversal, is completely impossible. And I'm not sure if this, if that side of things could actually be proven to be the case, that it's possible to reverse it all. There are some theories that could kind of demonstrate some portion of that. But it's all kind of postulate. Like, you can make as many simulations as you want that'll show the process of it happening. But unless you have the actual physical conditions necessary to do that, it's not going to happen. Like, it's not just it's not just going to flip around, because the actual generation of the field is based on having a liquid outer core. You can actually see some of this present in some planets around us. Like, if you have some planet with an iron core, which was rapidly cooled, right, and it retained its magnetic field, it would be able to retain that. But if you have one that cooled relatively slowly, supposedly, hypothetically, and if it had completely cooled in a sort of homogeneous manner, it wouldn't necessarily have produced a strong magnetic field. And you can test that hypothesis with, say, Mars. Mars doesn't have a magnetic field because it doesn't have a liquid outer core. No liquid outer core means no internal forces which produce a magnetic field. Earth has the conditions necessary to produce one, therefore we produce one. The Earth spins in one direction, it's going to keep spinning in that direction unless that changes. And when that changes, if that changes, then the field will flip. It's that simple. But that leaves me at the end of this discussion. I'm thinking my next major video topic might be philosophical impossibility of atheism. And if you have any more sort of suggestions for me to do for content in the future, because that philosophy one's probably going to take a while so that I can actually study properly, because most of my field of study has been in either the trades or on the engineering and physics side of things. If anybody has recommendations on philosophy texts for me to read in order to get more familiar with that material, please send them to me. I mean, I go by the handle Anthony Swapman on most things, or Swapman Anthony on some things. I'm present on Discord, on X, YouTube, Instagram, most platforms. So if you have some suggestion, send it to me. Anyways, that concludes part 3 of debunking the atheist zeitgeist. And that leaves me to the end. Au revoir. God bless. And I hope that everybody has a good upcoming Dormition fast for those celebrating on the New Style calendar. Anyways, au revoir again.